All right, so let's do an example. As I said before, we're going to pick a u value, and usually it's going to be something that's like on the inside of another function. So x to the fourth plus 2 looks like a pretty good candidate. The next thing is going to be taking the derivative of that u equation, which is going to be 4x to the third. Then we're going to work with some algebra. So we're going to multiply by dx to make this 4x to the third dx. Okay, go up to your integral and look at what you need to substitute. Remember, your goal is to make everything in terms of u. So as of right now, you have cos of u, which that's all good, but we need x to the third and dx to be replaced with something else. So I have x to the third dx right here. I just don't need this 4. So I'm going to multiply by 1/4 or divide by 4, basically to move it to the other side of the equation. So this now gives me something that I can plug in for x to the third dx. I'm going to plug in 1/4 du in place of x to the third dx. Okay, so let's rearrange all this stuff and kind of rewrite our integral. So I want the 1/4 on the outside because I prefer to move constants out there. And this is going to be cos of u du. Okay, now once you get to this point where all the variables are back in terms of u, you can antiderive. So the antiderivative of cos is sine. So we get sine of u plus c. And then remember, your final step is to change your u back into terms of x. So that makes it x to the fourth plus 2 plus c. Okay. Another example, I think, like I said before, I think choosing the whatever is inside of the radical is probably a good option. So we're going to let u be 2x plus 1. We're going to take the derivative, which would just be 2. And we're going to multiply by dx. Okay, so these 3 steps right here are kind of the same every time. This is where things get a little bit different. So inside the radical, we said is going to be u. I still need something to sub in for dx. So that means I need to divide by the 2. That way I can have dx alone on this side of the equation. So that means that dx is going to be equivalent to 1/2 du. And now we can rearrange all this stuff. So we have the 1/2 on the outside. Again, that's where I prefer to put it. You could put it in the inside the integral if you would like. And then we have the square root of u du. Now that everything is in terms of u, you can go ahead with your antiderivative step. So that means you would have u to the 1/2 power instead of writing the radical. And then you can do your little trick where you add 1 to the power and divide by the power. Plus c. And then remember, dividing by a fraction is the same as multiplying by its reciprocal. It's probably a little bit easier to solve that way. So we are going to end up with 1/3 u to the 3/2 power plus c. And then don't forget the last step is to plug the u, whatever you made u, plug that back in. There's your final answer. Okay, let's try another one with a radical, but this time we're going to have a little bit more to deal with. So we're going to make u 1 minus 4x squared. And then the derivative is going to be negative 8x. And then let's go ahead and multiply the dx over to the other side. And that's going to make it du equals negative 8x dx. Okay, here's where I like to reevaluate. So I've got this bottom part taken care of because all that's going to be u. But I still have an x and a dx that I need to sub something in for. So I have that like kind of right here. I just need to divide by the negative 8 to get the x dx all by itself. So I'm going to take negative 1/8 du, and I'm going to put that in place of all this stuff that's on the top, okay? Now, since all that stuff is on the top of the fraction, it's being removed, right? And negative 1/8 du is being put in its place. What you can do is just put the du over here on the outside and then put 1 on top, since technically there would be nothing left up there. You can just put like a 1 as a placeholder. All right, so I'm going to rewrite 1 over radical u as u to the negative 1/2 power, because that makes it easier to do the integration step. And now we can antiderive. So that means add 1 to the power, divide by the new power. So it would look like this, plus c. And then we can maybe clean this up a little bit. So remember, dividing by a fraction is the same as multiplying by the reciprocal. And that's going to leave me with negative 1/4. And I'm going to go ahead and change the u back to terms of x. So 1 minus 4x squared goes in the parentheses with a 1/2 power on the outside plus c. Keep in mind, you could, if you wanted to, you could rewrite this problem, this answer, as the square root of 1 minus 4x squared, since that is actually, it's actually the same thing as a square root, right, to the 1/2 power. Okay, easy example for the next one, which is not like a typical problem. I told you u is usually something that's in a radical, in a trig function, in a fraction. Well, this time we're going to make u the exponent. So let's have u be 5x. Let's take our derivative and we get 5. And then when we multiply by dx, we get du equals 5 dx. Okay, reevaluate. Right now I've got e to the u, but I have nothing in place of dx. So we're going to solve this equation for dx by dividing by 5. And so dx is going to be replaced with 1/5 du. And I'm going to choose to put the 1/5 in the front and du at the end. Now we can antiderive. So antiderivative of e to the u would be e to the u. And then change the u back to x variables, which was u was equal to 5x. So that is it. Okay, for tangent, what we're going to do is we are going to use substitution. The reason for that is there is no nice antiderivative for tangent. It's actually equal to this thing down here. But what we're going to do in order to like kind of explain that is we're going to go through the process and we're going to use substitution to do it. But let's start by changing tangent to sine over cosine. Okay, so we're going to go over here and we're going to say let's have u be equal to cos x. And then take the derivative, we get negative sine x and multiply dx over. So we get du equals negative sine x dx. So I already know that the bottom is my u. I need something for sine x dx, which I pretty much have that. I just need to move the negative over. So my antiderivative is going to look like negative 1 over u du. Okay, the antiderivative step is next. Antiderivative of 1 over u is ln of u. Plug your u back in. You get ln of cos x. Now, technically speaking, this answer is correct. It is not the same as the answer you see down here. Here's why. What the person, whoever wrote this solution down here, chose to apply logarithm properties. And logarithm properties allow you to take any negative, any number, I guess, in the front that is multiplying the logarithm and apply it as a power to the inside portion. And since this is being raised to the negative 1 power, that's the same as 1 over cos of x. and cos of x is equal, or sorry, 1 over cos of x is equal to secant of x. So again, not totally necessary to go these extra couple of steps, but I just wanted to explain to you why you're looking at something that looks a little bit different than what we had up here. Okay, so the AP curriculum writers decided that it is important that you also know how to antiderive using long division. Okay, so basically, use substitution's not going to work here because I can't substitute anything in to kind of equal every part of this problem. What we can do is we can use long division. So that means you are going to actually take the top and you're going to divide by the bottom, but you're going to use long division to do it. Okay, so to do long division, what you're doing is you start with 3x and you're going to say 3x times what is 3x squared? That would just be x. Then you're going to take x and you're going to multiply it through this outside divisor. So x times 3x is 3x squared. X times -1 is negative x. And then we subtract, which I usually just flip the signs, and combine like terms. Repeat that process. Now see 3x times what equals 6x? That would be 2. Let's multiply the 2 through the divisor. We would get 6x minus 2. Okay, subtract, which I usually just flip the signs, and we get 5. And then we're stuck because we have no more possible ways to divide. All right, let's interpret what this actually means. This actually means that this original integration question, the top divided by the bottom, is actually equal to x plus 2 plus the remainder. And the remainder is 5 over 3x minus 1. And then beyond that point, you're just going to antiderive what you have left here. So that would be x squared divided by 2 plus 2x. And then for this guy here, that's going to be ln of 3x minus 1. And actually, ln has a baby. So since we're doing an antiderivative, we would be dividing by the derivative of baby, which would mean divide by 3 plus c. So there's your antiderivative for this question.